Now, in 7, we just looked at the previous one, I think it was 5, and in that one we had some doubt about whether you needed to use a lot of collision theory ideas, but this one there's no doubt. Use your knowledge of kinetics to explain each of the following statements. So we're going to be thinking about the 2 ideas in collision theory and seeing how they show up. 1, things have to collide with enough energy to react, and 2, they need to collide with enough with the correct orientation. So A, an increase in the temperature at which a reaction takes place causes an increase in reaction rate. Alright, so here's my explanation. At higher temperatures, a larger fraction of molecules collide with sufficient energy needed to overcome the energy of activation. Remember that hump, that energy of activation is how much energy they need to do the reaction. Many of them will not have this much energy to overcome it, and that's why reactions are slow. The more molecules that do this, as in have enough energy when they collide, the faster the reaction rate. So going back to collision theory, it's how hard they hit, essentially, without using that sort of sloppy language. B, the addition of catalysts increases the rate at which a reaction will take place. So I think the orange part down here is really all you would need. If you wanted to do more, you could do the black part. So a catalyst will lower the energy of activation by providing an alternative reaction pathway. I even think this first part, a catalyst will lower the energy of activation, is probably enough. That would be enough. Now you might want to say, well, why does that matter? And that might be a different direction you want to go. Like, try this. Yeah, I actually like this better. We do know that a catalyst may create an intermediate that fixes the orientation. That's true. I think you definitely get credit for that. Any reasonable answer. But I kind of like this direction better. A catalyst will lower the energy of activation. And why does that matter? Because a lower energy of activation means that more molecules will collide with sufficient energy to do the reaction, thereby increasing rate. And I didn't have enough room to write increasing, but you definitely would want to do that. So you notice a catalyst has 2 roles here, and I don't think it really would matter which way you went, with the fixing the orientation issue or just lowering the energy of activation. But saying the impact of it probably would be important. Part C, a catalyst that has been ground into a powder will be more effective than a solid block of the same catalyst. Okay, so the powder will create more surface area. Maybe I should have said than the block. But anyway, grinding something into a powder will create more surface area. More surface area allows more of the powder molecules to collide with other reactant molecules. And more collisions equals a faster rate. You might look how informal this last part is. I think that's okay. I think that's perfectly fine. Be even nicer if you had a diagram, like you showed a block with lots of little particles in there like that. You had the outside reactant molecules, and they just can't get in there. They can only react on the surface. Versus if you had powder, you ground it up into powder, then the external black spots would easily be able to work their way in, and there would be much more surface area, better odds of collisions. And in D, increasing the concentration of reactants increases the rate of reaction. And this is pretty similar to what we saw in the previous problem. Increasing the concentration of reactants improves the odds of 2 molecules colliding. So we're going back to collision theory. You notice the orientation thing should not play a role here, because having more is not going to improve the odds of them colliding with the correct orientation. So more collisions equals a faster rate. I use this sort of shortcut away here again. I'm trying to decide if I haven't been thorough enough. So let me think. Why do improved number of collisions cause faster rate? I mean, we could go on to say, well, we know that in many reactions a small percentage of the collisions result in a reaction, so obviously the more collisions you have, the better the rate. You could do that. I think this would be enough, but you certainly could ask that question, why? Now you'll notice what I'm doing here is I'm trying to model what you should be doing, which is trying to think about how deep do they want you to go. And in kinetics questions, if they're qualitative like this, collision theory is almost always the answer. And remember the 2 parts of collision theory? They are molecules must collide with sufficient force, and molecules must collide with the correct orientation. Those are the 2 things you need to get a reaction to occur. And they should guide your thinking in all of these sort of qualitative problems.